Tonight, we are going to talk about something big. Really big. We are going to talk about distance in space. Not the distance to school. Not the distance to another city. We are talking about the distance to the moon, to other planets, to other stars, and to other galaxies far, far away. Light is the fastest thing there is. Nothing moves faster than light. But even light needs years and years just to reach the closest star. And it needs millions of years to reach the next galaxy. Some galaxies are so far away that they are moving away from us faster than light can even travel to them. This is not something we can fix by building a better rocket. This is just how big space is. It decides what we can see, what we can learn, and what we will never, ever be able to touch. By the end of this story, you will understand just how big space really is. And the more you learn, the bigger and stranger it gets. Let's start close to home. The moon is the closest big thing to Earth. It is about 239,000 miles away. We have actually been there. Astronauts landed on it and came back home. It is the only other place in space that humans have ever walked on. It took about 3 days to fly there. 3 days sounds like a long trip. But light can travel that same distance in just over 1 second. During the moon missions, when astronauts talked to people on Earth, there was a small delay, because even light needs a little time to travel that far. And the moon is the closest thing out there. Everything else is much, much farther. Next comes Mars. Mars is often called our neighbor planet. It's the planet we are trying hardest to visit. Mars is about 142 million miles from the Sun, while Earth is about 93 million miles from the Sun. Because both planets are moving, the distance between Earth and Mars keeps changing. Sometimes Mars is about 34 million miles away. Other times it is over 250 million miles away. Light takes about 3 to 22 minutes to travel from Earth to Mars, depending on where the two planets are. That means if a robot on Mars runs into trouble, we won't find out for at least 3 minutes. And our help won't arrive for 3 more minutes after that. This is why space scientists cannot control a Mars robot like a video game. They have to plan every move ahead of time, send the instructions, and then wait. And Mars is still one of the closer planets. Farther out is a belt of rocks called the asteroid belt. Past that is Jupiter, the biggest planet in our solar system. More than 1,300 Earths could fit inside Jupiter. Light takes about 33 to 52 minutes to travel from Earth to Jupiter. Next is Saturn, famous for its beautiful rings. Light takes over an hour to reach Saturn. Then comes Uranus, where light takes about 2.5 to 3 hours. Then Neptune, the farthest big planet, where light takes about 4 hours to arrive. We actually sent a spacecraft to Neptune. It was called Voyager 2. It launched in 1977 and reached Neptune in 1989. That is 12 years of traveling just to fly past one planet, take some pictures, and keep going. Every picture Voyager 2 sent back took 4 hours just to arrive on Earth. But scientists were still very happy. After 12 years of traveling, the spacecraft arrived right on time and sent back amazing pictures of Neptune's deep blue color and its icy moon. Voyager 2 kept flying and never stopped. Today it is about 12 billion miles away. A signal now takes about 17 hours to reach it. That means if scientists send it a message, they wait 17 hours for it to arrive, then wait another 17 hours to hear back. That's 34 hours just for one short message and reply. And Voyager 2 is still not even close to leaving our own solar system. Most people think the solar system ends at Pluto, which is about 3.7 billion miles from the Sun. But that is not even close to the true edge. The Sun's pull, its gravity, reaches much, much farther. Far beyond Pluto is a giant cloud of icy space rocks called the Oort cloud. We have never actually seen anything inside it directly, because it is too far away and too dark. We only know it's there because of comets that come from it every once in a while. The Oort cloud starts about 186 billion miles from the Sun and stretches out to about 9.3 trillion miles. That is almost a light year and a half away. That is how far the Sun's pull reaches into space. Voyager 1, the farthest human-made object ever built, is flying at about 38,000 miles per hour. It won't even reach the inner edge of the Oort cloud for another 300 years. And once it gets there, it will take about 30,000 more years just to fly through it. That is the true size of our own solar system. And we haven't even left it yet. Now let's really leave. Past the Oort cloud is empty space between stars. The closest star to our Sun is called Proxima Centauri. It is 4.24 light-years away, which works out to about 25 trillion miles. If Voyager 1 could fly straight toward that star, at its current speed, it would take about 78,000 years to get there. All of human history is only about 5,000 years long. We would need human history to repeat itself 16 times over just to arrive at the nearest star. Our fastest spacecraft ever built is called the Parker Solar Probe. It has reached speeds of about 430,000 miles per hour by flying very close to the Sun. Even at that speed, flying to the nearest star would take about 6,500 years. The Great Pyramid in Egypt was built about 4,600 years ago. Our fastest machine ever built still needs longer than that just to reach our closest star neighbor. So what is Proxima Centauri actually like? It is a small, cool, dim star called a red dwarf. Most stars in our galaxy are actually red dwarfs like this one. Proxima Centauri is so dim that even though it is the closest star to us, you cannot see it without a telescope. It does have a planet, discovered in 2016. But that planet circles very close to its star, closer than Mercury circles our Sun. One side of the planet probably always faces the star in bright heat, while the other side is stuck in permanent darkness and cold. And the star sometimes blasts out huge bursts of energy, much stronger than anything our own Sun makes. It would be a very harsh place to live. Proxima Centauri actually belongs to a group of 3 stars, called the Alpha Centauri system. If you stood on a planet near one of those other stars and looked back toward us, our Sun would just look like a small, ordinary point of light in the sky. 25 trillion miles away. For years of travel time, even for light. Let's zoom out even more. Within about 16 light-years of our Sun, there are only about 50 to 60 other stars. That might sound like a lot, but space is so huge that these stars are still spread very far apart from each other. There's Barnard's star, about 6 light-years away. There's Sirius, the brightest star in our night sky, about 6 light-years away. When you look at Sirius tonight, you are actually seeing light that left that star 8.6 years ago. Anything that has happened in your life since then, Sirius doesn't know about yet, in a way of speaking, because its light hasn't shown us anything new since then. Every single star near us is completely impossible to reach with the spacecraft we have today. Even the very closest one would take thousands and thousands of years to reach. And our little star neighborhood is just a tiny piece of something much, much bigger, our galaxy, the Milky Way. The Milky Way has somewhere between 200 billion and 400 billion stars. Nobody can count them one by one, so scientists estimate the number using math. The Milky Way is shaped like a big, flat, spinning disk. It is about 100,000 light-years wide. Our Sun sits about 26,000 light-years from the very center of the galaxy. The whole solar system is slowly spinning around that center, moving at about 483,000 miles per hour. One full trip around the galaxy takes about 225 million years. The last time our Sun was in this same spot, dinosaurs hadn't even appeared on Earth yet. At the very center of our galaxy, hidden behind thick clouds of dust, is something amazing, a giant black hole. It is about 4 million times heavier than our Sun, even though it isn't much bigger in size. Scientists tracked a star flying super close to it, moving at more than 2% of the speed of light, just to prove the black hole was really there. In 2022, scientists finally took a real picture of this black hole. But the picture is blurry, not because the cameras are bad, but simply because it is 26,000 light-years away. That light left the center of our galaxy back when early humans were still painting pictures on cave walls. If you tried to cross our whole galaxy at the speed of light, it would take 100,000 years. At the speed of our fastest spacecraft, it would take about 1.8 billion years, which is a huge chunk of the entire age of the universe. And that's just for one galaxy, out of 2 trillion galaxies that we know about. Our galaxy alone has more than 5,500 confirmed planets around other stars that we've found so far, and scientists believe nearly every star has at least one planet. That means our galaxy might have hundreds of billions of planets. About 1 billion of them might even be rocky planets sitting in the right spot to possibly have life. And every single one of them is impossible for us to reach. Our galaxy is not alone either. It belongs to a group of more than 60 galaxies called the Local Group. Our closest big neighbor galaxy is called Andromeda. It is 2.5 million light-years away. Our whole Milky Way is 100,000 light-years wide, so the gap to Andromeda is 25 times bigger than our entire galaxy. Andromeda is a little bigger than our galaxy and has about 1 trillion stars of its own. In about 4.5 billion years, our galaxy and Andromeda will actually crash into each other. But because stars are so far apart from each other, it won't be like cars crashing. It will be a slow, gentle mixing that takes billions of years. Andromeda is the farthest thing you can see with just your own eyes, no telescope needed. It looks like a tiny, faint smudge in the night sky. The light you see left that galaxy 2.5 million years ago, long before humans even existed. It has been traveling this whole time, just to reach your eyes tonight. Zoom out even more, and our local group is part of something even bigger, called the Virgo supercluster, which is about 110 million light-years across. Inside it is a huge group of over 1,000 galaxies called the Virgo cluster. In 2019, scientists took the very first real picture ever of a black hole, found in a giant galaxy inside this cluster. That black hole is 6.5 billion times heavier than our Sun. The light in that picture had been traveling for 54 million years before it reached us, from a time when the dinosaurs had only just gone extinct. Zoom out again, and even that supercluster is just part of something bigger. In 2014, scientists mapped out an enormous structure of galaxies all being pulled together by gravity. They named it Lania Kea, which means immeasurable heaven. It stretches about 500 million light-years and contains about 100,000 galaxies, all slowly falling toward each other. Now zoom out to the very biggest picture of all, the whole universe that we can actually see, called the Observable Universe. Because light takes time to travel, and because space itself keeps stretching and expanding, the edge of what we can ever see is about 46 billion light-years away in every direction. That makes the observable universe a giant ball about 93 billion light-years wide. Inside that ball, there are about 2 trillion galaxies. Each one has hundreds of millions to trillions of stars inside it. The total number of stars we can see is so big that if every star were a single grain of sand, you would need about 10 giant swimming pools completely full of sand just to have that many. And here's something strange. The universe is not just big, it is actually growing bigger, faster and faster, all the time. Scientists call whatever is causing this dark energy, even though nobody really knows exactly what it is. Because of this stretching, some galaxies are moving away from us faster than light can even travel. That means their light will never reach us. Ever. Even though we can technically still see some of those galaxies right now, they are already too far to ever visit, even with a spacecraft traveling at the speed of light. There is one more strange thing about looking into space. When you look at something far away, you are not seeing it as it is right now. You are seeing it as it was a long time ago, because that is how long the light took to travel to you. Looking at the moon shows you the moon from over a second ago. Looking at the sun shows you the sun from about 8 minutes ago. Looking at Andromeda shows you light that is 2.5 million years old. The night sky is like a time machine. Every star you look at is showing you the past, not the present. So what would it actually take for humans to travel to another star? To make the trip in about 100 years, a spacecraft would need to travel at about 4% of the speed of light. That means going about 60 times faster than our fastest spacecraft ever built. Normal rockets simply cannot do this, because the more fuel you carry, the heavier you get, and the heavier you get, the more fuel you need. It becomes an impossible loop. Scientists have some wild ideas, though. One idea is called a laser sail. Instead of carrying fuel, a tiny spacecraft would have a giant, thin sail, and a powerful laser on Earth would push it forward using the pressure of light itself. In theory, this could get a tiny probe up to 20% of the speed of light. At that speed, a trip to the nearest star would still take about 21 years, plus a few more years just for the data to be sent back to Earth. And the giant laser needed for this doesn't even exist yet. We have also been sending out radio and TV signals into space since the early 1900s. That means our signals have only traveled about 240 light-years out into space so far, which is a tiny, tiny distance compared to the size of our galaxy. If there is another civilization out there more than 300 light-years away, they haven't heard anything from us yet, and we haven't heard anything from them either. It might not mean nobody is out there. It might just mean space is far too big for signals to have reached each other yet. There is one more amazing way scientists have found to listen to the universe. In 2015, scientists detected something called a gravitational wave for the very first time. This is a tiny ripple in space itself, caused by two giant black holes crashing into each other over 1 billion light-years away. The ripple traveled all that distance and was finally picked up by super-sensitive machines on Earth. It won scientists a Nobel Prize, and since then, they have detected many more of these ripples from crashes happening all across the universe. Scientists have also found the oldest light in the whole universe. It is called the cosmic microwave background. It comes from a time when the universe was only 380,000 years old, right after the universe first became clear enough for light to travel freely. This light has been traveling for over 13.8 billion years, and it reaches us from every direction in the sky, all at once. It is like a baby picture of the entire universe. So let's step back and look at everything together. The Moon is 239,000 miles away. Mars is millions of miles away. Neptune is billions of miles away. The edge of our own solar system is trillions of miles away. The nearest star is 25 trillion miles away. Our galaxy is 100,000 light-years wide. Andromeda is 2.5 million light-years away. And the whole universe we can see stretches out 93 billion light-years in every direction, inside a real universe that might be even bigger, maybe even endless. Every single one of these numbers is real. They have all been measured by real scientists using real tools. And together, they tell us something important about where we live. We are on a small rocky planet, circling an ordinary star, inside a galaxy with hundreds of billions of stars, which is just one of 2 trillion galaxies that we know about. The Moon took us 3 days to reach. Mars would take months. The nearest star would take our fastest spacecraft tens of thousands of years. The center of our own galaxy would take hundreds of millions of years. Reaching Andromeda would take billions of years. These distances are not just big. They are so big that they place almost the entire universe forever out of our reach. Not just for now. Maybe forever. But here's the amazing part. Even though we have never left the area around Earth and the Moon, humans have still managed to measure the size of the entire universe. We have taken pictures of black holes millions of light-years away. We have heard the ripples from crashes that happened over 1 billion years ago. We figured all of this out using math, science, and curiosity, all from right here on this one small planet. There is still so much we don't know. We don't fully understand dark energy. We don't know exactly what happened at the very beginning of the universe. We don't know if the universe goes on forever. We don't know if anyone else out there, on one of those billion possibly Earth-like planets, is looking back up at their own night sky, wondering the exact same things we are. But we know enough now to understand just how big it all is. And understanding that, really understanding how small we are compared to it all, might be one of the most amazing things humans have ever done. So go outside tonight, if you can. Find a dark spot, away from city lights, and look up. Every single point of light up there is a star, like our own Sunday. Most of them probably have their own planets circling around them. And every single one of those lights took years, or even thousands of years, just to reach your eyes tonight. Some of those stars might have already changed, or might not even exist anymore. Their light just hasn't finished its journey to tell us yet. You are not looking up at a ceiling. You are looking through a window, into an ocean of space so old and so wide that words can barely describe it. And we just keep looking up anyway. Good night.